Ensuring the delivery of the data, one of the fundamental concepts in the design for TCP is that every octet of data, or every byte of data that's sent over a TCP connection has a sequence number, and since every one of these bytes is sequenced, each one of them can be acknowledged. Now, we don't acknowledge every one typically, but if you remember my example a while ago, if I acknowledge 101, that's telling you that I've received up through 100. So assuming you may have started your sequence number at 50, so if I acknowledge 101, I've gotten all the bytes you've sent corresponding to your sequence number 50 through 100, and I did it all with one acknowledgement. So you don't have to acknowledge every single byte. We acknowledge blocks, and that cuts down on traffic and allows things to be more efficient and actually for us to move more data. The acknowledgement mechanism employed is cumulative. That's what I just got through telling you. So that the acknowledgement of sequence number X indicates that all the octets or bytes up to but not including X have been received. So we don't have to acknowledge byte by byte, and that's an important concept. We also have some flags here. Each of these tells it's set by these are set by the source, and interpreted by the destination. You got an urgent pointer, an acknowledgement pointer. We just talked about the acknowledgement. It's not an acknowledgement pointer, it's an acknowledgement flag. These are all a single bit. So what you have here is 6 bits of flags. So we have an urgent pointer bit that could be a 1 or a 0. You could say that for all these. Could be 0 or 1, not set or set would be other terminology. So we have an acknowledgement bit, we have a push function bit, we have a reset bit, synchronize sequence numbers. This is used to generate the initial sequence numbers when we're setting up a connection. And then we have a fin bit that's used to terminate a session. So these are the control flags. Usually we just refer to these as the TCP flags. Window size is a 16-bit field, and it indicates the number of data bytes, beginning with the one indicated in the acknowledgement field, which the sender of the segment is willing to accept before it's expecting an acknowledgement, or it's going to send an acknowledgement. By increasing your window size, you can potentially send more data before the sender is going to stop and wait on an acknowledgement. So, if you've got a really dependable network, you can the TCP stacks on these two computers will negotiate a larger window size, and this will make it possible to more effectively. It's going to make it possible to move more data before acknowledgement has to be sent, which kind of makes things more efficient. Not much more we're going to say about that in this class. Establishing TCP IP, this is a TCP session, it's not a TCP IP. It's a 3-step process, usually referred to as a 3-way handshake, and these are the 3 parts to this. The initiating machine or device sends a packet with the send flag set to the receiving machine. Now, this is basically saying to the receiving machine, I want to talk. The receiving machine sends back a packet with both the send and the ACK flag set. A couple things going on here. Number one, the ACK flag says, okay, I want to talk. I understand you want to talk. The send flag says, I want to talk too. Now, the send flag also indicates that the header contains an initial sequence number. Now, if you remember a while ago, I pointed out to you that if I'm talking to you, I'm keeping up with every byte of information I send. I have every byte that I send has a sequence number. So that's my sequence numbers. And when you acknowledge receiving those, you're going to acknowledge my sequence number. When you're talking back to me, and you will be, you're going to establish, your computer's going to establish its own sequence number, which is different than mine. So when I acknowledge receiving something from you, I'm actually acknowledging your sequence numbers. So any TCP conversation, or session, if you will, has two different sets of sequence numbers. So if the send packet is set, that is the initial sequence number. And again, remember, these should be randomly determined anywhere in this possible 32-bit field. Typically, they are a certain offset from the previous one that was used, so they're not truly random, and that causes us some problems as far as security. So that's the first two of the three-way handshake. First two parts of the three-way handshake. The third part is the initiating machine sends back a packet with the acknowledgement flags set that says, I acknowledge that you want to talk. And when the acknowledgement flag is set, there's actually acknowledgement numbers that are contained in these packet headers. So we'll see how these work here in a moment. Here's a diagram of this. In this case, we've got two workstations talking to each other, and the one here on the left is going to initiate the session. And it's going to do so by sending a packet with the send flag set to workstation 2. This packet says, in effect, that workstation 1 wants to talk. And it's going to start the numbering of what it wants to say with the number 1000. So, again, this is just should be randomly generated. It's really not, but it should be randomly generated. Now, this is the initial sequence number. This is the ISN. Now, notice in this first packet, the acknowledgement flag is not set, and the acknowledgement number is 0, because this is the opening packet, and this would acknowledge the sequence number of this computer, and we don't know what its sequence numbers are yet. So that's why the acknowledgement number in a send packet should be 0. Now let's look at the second part of this, the second packet coming back from workstation 2. Workstation 2 replies with a packet that says, I acknowledge you want to talk, and I want to talk too. This sets both the send and the ACK flags. Workstation 2 sends the sequence number for its communications. Now it picks sequence 750. Now just pick these numbers. They're small. Remember, this is a 32-bit number, so in the real world these are probably going to be very large numbers. So don't panic when you see something higher than 1000 as a starting point. And the acknowledgement here says we're going to send an acknowledgement number of 101. This tells workstation 1 that the next data byte it expects from workstation 1 should be byte 101. So the third part of this is workstation 1 completes the setup by sending back an ACK packet. And this is telling workstation 2 that it acknowledges it wants to talk to. And it tells workstation 2 that the next data it expects from workstation 2, it starts with byte 751. So there's 751. Notice that the sequence number here didn't change because we really haven't sent any data back over here from workstation 1 to workstation 2. A TCP connection goes through this three-way handshake every time connection is established. And we're going to we'll use Wireshark to look at some of these. Now, there's another implication here to this. And I think I'll just wait and talk about that later. I don't want to confuse you too much. But you really do need to understand how the three-way handshake works. In this case, we're just talking about the sequence numbers. You might make a little note here. There's nothing on here on this slide about TCP ports. And there are port numbers involved in this transaction. The implications of this I'll talk about later on. So this slide is just about sequence numbers and acknowledgement numbers. Now here's a real packet capture. This is ethereal. Ethereal still out there. There's also something kind of going on in parallel here called Wireshark. They look just alike, at least so far. So this is a packet sniffer, or packet capture software. It actually looks on the wire and it shows you the contents of the packet. Notice that this particular packet I have highlighted here is a SYN packet. And you can go down here, the middle window here, it can be expanded to show you packet contents. Notice that the SYN flag is set. The bottom window here actually shows you a hexadecimal representation of the actual ones and zeros. So these down here are packet contents. And remember, the packet could have, at any particular time we might be looking at data, we might be looking at a header. Packet contents in hex. So the actually what you're going to be looking at is ones and zeros. Ethereal or Wireshark or most packet sniffing software will actually convert those into hex for you. It's easier for you to read in a lot of cases. So here we have in this case, SYN packet. You might also notice here that the source port for this was 3241, and again, this was chosen by the workstation that initiated this. Destination port is 80. In all likelihood, this traffic is this packet was directed to a web server. And if you notice up here underneath this, we get back from the web server a SYN ACK packet, and then this computer sends a final ACK. Then it turns right around and actually generates an HTTP GET statement. This actually requests I don't know why I'm having trouble with a lot of trouble with my pen today. I'm hoping the next generation of tablets has a better technology. So what you see here, this is the actual web page request. So notice the actual request wasn't sent until the three-way handshake had set up the connection. So whenever you're using TCP, the connection is set up first, and then after the three-way handshake is when the actual data starts to flow. Now, what I've done here is I've used Ethereal to look at the contents of just certain packets. and this is the SYN packet, you can, I'll leave this up to you, you can download this little slideshow here and actually compare the numbers. The first one showing the contents of the SYN packet. This is the sequence number that, again, this is the initial sequence number. The TCP IP stack on this computer picked this number, supposedly at random. It's probably based on the previous, the number was used previously. Notice there is no acknowledgement number displayed here. Ethereal is smart enough to realize that there's, since this is a SYN packet, there is no acknowledgement number. If I back up here, it kind of messes up my movie, but you can probably look back in the previous slide there and see if there was actually an acknowledgement number in that packet that was sent. And I bet there's not. Ethereal's also decoded the flags for us. It actually shows 2 more flags than what we talked about before. So these are additional flags that are used sometimes now. So that brings to 8 the number of flags. The one we're interested in here is the SYN flag. Only a SYN or a SYN-ACK packet should have the SYN flag set. Any other packets that have that, pretty good chance somebody's up to something that they shouldn't be doing. The maximum segment size here is 1460 bytes. This is actually this is going to be the size of the data that we're going to be sending. Here's the SYN-ACK packet. Notice here that the source port, destination port are now reversed. So this destination port here was the source port on the previous SYN packet. This is how the initiating device is going to keep up with what to do with this packet. It's going to look at the destination port and say, okay, I know what was sent out from that port. This goes with that. We were trying to establish a connection with the web server, so I know what to do with this. Notice here that the acknowledgement number, this is an acknowledgement to the sequence number in the SYN packet. And this is a different number. This is the ISN for this session for the web server. So again, there's 2 different sets of ISNs and acknowledgement numbers that are used in this session. Notice in this case, our flags, we have the acknowledgement bit set and the SYN. So we have a SYN-ACK packet here. Now, let's look at the final packet here. This is the ACK packet. Again, notice the source port, destination port have reversed again back to what they were in the first packet. Notice here that the sequence number corresponds to the number of workstation 1. The acknowledgement number here is acknowledging what was sent from the server. In this case, we only have the ACK flag set. Once we get up and rolling with our communications here, the ACK flag is should be the only one that's set. You shouldn't see SYN again because we've got everything set up. The acknowledgement flag being set is telling the receiving computer to check the acknowledgement number so it can keep up with what it needs to send next. So spend some time studying the relationship between these numbers. These last three slides have shown you how the source and destination port flip depending on which direction the packet's going, and the sequence number shows you there's two lines of communications going on. It's like I'm talking to you and then you're talking to me. It's two-way communications. There's two streams to be kept up with.